Welcome to part 2 of the 4.5 lecture on solving quadratics by using square roots. Part 1 was all about just how to simplify square roots, and it was really long and a lot of examples. This is going to be a shorter lecture, and this is going to be specifically talking about how to solve using the square roots. So we're going to have equations that have x squared somewhere in it equal to something, and we have to find out what value of x would make this a true statement. We have some steps here. Number 1 is to solve for the thing that is being squared. So look at what's being squared and get that by itself. Step 2 is going to be to take the square root of both sides. That the square root and the squared cancel each other out. They get rid of each other. And that's going to be our goal, is to get x by itself. So the way to get rid of a squared is to take the square root. Whenever you take the square root of both sides like this, it's going to create a plus or a minus. It's going to create two different answers, one positive and one negative. And then sometimes you're going to need to solve that equation further, and you would do that at this time. So let's look at some examples. We're going to start very simple, very straightforward, and then progressively get more difficult. So step 1 says to solve for the thing that is being squared. X squared is equal to 169. The thing that is being squared, which is x, is already solved for. So step 1 is done here. Step 2 says to take the square root of both sides. So in order to get rid of this squared sign, you would take the square root of both sides. If you do it to one side, you have to do it to the other, right? The square and the square root cancel each other out, and so we just get x over here. But whenever you do that, you take the square root of both sides, it's going to create a plus or a minus. And the square root of 169 is 13. Solve further if needed. X is already by itself here, so we don't need to solve further. Our answer is just positive 13 or negative 13. Very simple to check. You should be able to take the number 13 and square it and get 169, or negative 13 and square it and get 169. Remember, if you want to square the number negative 13, it has to be in parentheses. Let's then look at this example. Step 1 is to solve for the thing that's being squared. Well, what's being squared? It's x. So you want to solve for x squared. You're going to need to get rid of the minus 10 and the multiply by 7. So just like if I had the 7x minus 10 is equal to 25, my first step would be to add 10 and then divide by 7. It's going to be the exact same here. So you'd have 7x squared is equal to 35 when you add 10 to both sides. Then you would divide by 7 because I want to get the x squared by itself. And it has this multiply by 7. The way to undo that is to divide by 7. So then you would have x squared is equal to 5. That was step 1. I solved for the thing that's being squared, which is x squared. Then you take the square root of both sides. Taking the square root of both sides, the square root cancels out the square, so you just have x. If you do that to one side, you have to do it to the other side, remembering that when you do that, it creates a plus or minus. So there's going to be two answers here. I guarantee I'm going to be taking off a lot of points for people forgetting about the plus or minus. Happens every year. So remember, whenever you take the square root of both sides, it creates a plus or minus. Like I said, we're going to progressively get more difficult. Here we're going to add 40 to both sides. That would give us 2x squared is equal to 64. The reason that we're doing that is because we're solving for the thing that is being squared. Then you would divide both sides by 2. The thing that's being squared is x. I need to get rid of that multiply by 2. So then you'd have x squared is equal to 32. From here, you would take the square root of both sides, right? That's part B now, because that's what gets rid of the squared, and you would get x is equal to plus or minus the square root of 32. If you come up with a decimal here, you are going to be 100% wrong. I don't want a decimal here. What I want you to do is I want you to use this stuff from the first lecture in 4.5 and figure out how to simplify the square root of 32. The square root of 32 has perfect square factors. The biggest one is 16. So this would be x is equal to plus or minus square root of 16 square root of 2. Remember, you break it up as its perfect square factor, and 16 times what is 32? 16 times 2. That's how you get these both of these numbers. Final answer, x is equal to plus or minus 4 root 2. And the reason that we do that is because we know the square root of 16 is 4. Carrying on. Same couple first steps. Add 4 to both sides. 3x squared is equal to 16. Divide by 3 on both sides. You get x is equal to 16 thirds. Do not change this into a decimal or you'll be wrong. From here, you would take the square root of both sides. We're going to be using the properties that we talked about in the first part of the lecture. Taking the square root of both sides creates the plus or minus, and then you have the square root of 16 over 3. So x is equal to plus or minus. Remember, if you have a fraction underneath the root, you apply the root to the numerator and the denominator. X is equal to plus or minus. The square root of 16 is 4 over root 3. And hopefully you remember that we're not allowed to have a root in our denominator. And so what we did is we multiplied by the number 1, but that doesn't look like the number 1. If it's just one root in your denominator, you just write that as the numerator and denominator. This is effectively the number 1, right? Because anything divided by itself is 1. So then we have x is equal to, multiplying the numerators across, you get 4 root 3. And multiplying the denominators across, remember, root 3 times root 3 is just 3. That's your final answer. X is equal to plus or minus 4 root 3 over 3. I believe we have 2 more examples that we're going to talk about. Remember, step 1, if it was written here, would say solve for the thing that's being squared. In this example, the thing that's being squared is x minus 4. So I need to solve for this whole thing. I'm going to do that by adding 18 to both sides. And then dividing by 2 on both sides. And now I've solved for the thing that's being squared. That was step 1 in blue. Step 2 is to take the square root of both sides. So then I would have x minus 4 is equal to plus or minus the square root of 34. I'm going to try to simplify the square root of 34 if I can. But off the top of my head, I don't see any perfect square factors of 34. There's no numbers in that big long list that are factors of 34. So the 34 part is simplified. Now that step 3 is going to come into play. Step 3 said to solve further if needed. And x isn't by itself yet. I need to add 4 to both sides. So I have a positive 4 that needs to be added over here. Rather than putting a plus 4 right here, we like to write that number in front. So this would look like 4 plus or minus the square root of 34, and that's my final answer. Why don't you guys try this one? Pause it here, see how you do, and then work with me as I go over it. First step would have been to add 18 to both sides. So you'd have 2 times x plus 3 squared is equal to 49. Then you would divide by 2 on both sides. So you'd have x plus 3 squared is equal to 49 over 2. If you wrote this as a decimal, you would have been wrong. So all of that was in the first step here. I solved for the thing that was being squared. Step 2 said to take the square root of both sides. Remembering that taking the square root of both sides creates a plus or minus. I'm going to go ahead and start working on simplifying this. So that would be x plus 3 is equal to plus or minus the square root of 49 over the square root of 2. And then I know that the square root of 49 is 7. And I'm not allowed to have a root in my denominator. So what do? I multiply by 1. That's not 1. It's going to be whatever is in the denominator, right? Root 2 over root 2, because that's what the denominator was. So it would equal plus or minus 7 times root 2 is just 7 root 2. And root 2 times root 2 is just 2. So that was all in step 2 of our 3 steps. And then step 3 said to solve for x further if needed. So we need to subtract the 3 over, and we get negative 3 plus or minus 7 root 2 over 2. That's all I have for you guys for part B of this lecture. Please let me know if you have any questions. Please make sure you're attempting these problems. They are very difficult and crucial, but you can definitely do it when you put in a little bit of time. So let me know if you have any questions. Thanks.